Hello, my name is Jolene Rhodes, and in this lesson we're going to use Gaussian elimination to solve systems of equations. In order to solve systems of equations with Gaussian elimination, we first have to understand that what we're going to do if we have a system, and I am going to just start with an example of a system. So for example, if I have the 2 by 2 two equations, two variable system, x minus 5y equal to 11 and 2x plus 3y equal to negative 4. In order to use Gaussian elimination, the first thing we do is we create what we call an augmented matrix. An augmented matrix is simply a matrix which has the coefficients of each of the variables. So we would use the coefficient of x, which is 1, the coefficient of y, which is negative 5, coefficient of x in the second equation, and the coefficient of y in the second equation. So we write the matrix of the coefficients. We are then going to separate that from the solutions to those equations. So what we're going to do is, that's called an augmented matrix. So not only do we just have the coefficients of the variables, but we also have the solutions to each of those equations also represented in our matrix. Now, the goal in Gaussian elimination is to put this matrix, or any matrix that you get from the system, into what we call row echelon form. And row echelon form for a square matrix, any square matrix, and so that basically means we're looking at the coefficient parts of that matrix above. If we were looking at a matrix in row echelon form, what we would like is to have ones on the diagonal, zeros below that diagonal, and it does not matter what the terms are, the elements are above the diagonal. So row echelon form for a 2 by 2 would look like that. Row echelon form for a 3 by 3, again, ones on the diagonal, zeros below that diagonal, and then these elements can be whatever they end up being in that matrix. So row echelon form looks like that, and that's our goal for these when we go ahead and solve with Gaussian elimination. So what we're going to do is now, in order to do that, there are 3 steps that we are allowed to use to change our matrix from the form it's in order to get it into row echelon form. So there are 3 steps that we are allowed to take. The first thing we are allowed to do to a matrix is we are allowed to interchange 2 rows of the matrix. So if perhaps we have a 1 in one of the rows, but not in the one that, but not where it, in the position we want it in, we are allowed to interchange 2 rows. We are also allowed to multiply any row by a non-zero constant. So we can multiply the row by a non-zero constant. And the third thing we are allowed to do is we are allowed to add a multiple of one row to a different row. Now again, ultimately, we would like our matrix to be in row echelon form. The only 3 things we're allowed to do in order to convert our matrix into row echelon form are: we can interchange 2 rows, we can multiply a row by a non-zero constant, or we can add a multiple of one row to a different row. Now if we take the example that I gave you above, so we're going to start with this augmented matrix: 1, negative 5, 11, 2, 3, negative 4. What we can see is the first step to this process is actually to get a 1 in position 1, 1. That means the element in row 1, column 1, we do want to be a 1 in row echelon form, as you can see above. This one is already a 1, so step 1 is done for us. Now when we work our way towards row echelon form, the next step is to get a 0 or zeros in the rest of that column. So we're going to work one column at a time. So we go for the 1 in the first position of column 1 and then zeros in the other positions of column 1. Now what we can see right there is that we do have a 2. That's certainly not a 0. What I'm going to do is number my rows right here so that you can see them. So this is row 1, this is row 2, and what I want is a 0 in the first position of row 2. So not going to do anything to row 1. So I'm going to leave row 1 alone in this matrix. We're going to just write it down and leave it there. Now what I want is a 0. And if I look, and this is similar to solving systems of equations with elimination, what we're going to do is simply multiply row 1 by -2 and then add it to row 2. So what I want to do is I want to take row 1, I'm going to multiply it by -2, I'm going to add it to row 2. So I'm going to add a multiple of one row to the other row, and then what I'm going to do is put that right in this bottom row. So what we're going to do is we're going to change row 2 by adding it to a multiple of row 1. So what we're going to do then is, as I said, we're going to take 1, this number right here, times -2 is -2, plus 2 is 0, and that will go right here. We have to continue that process all the way across. So again, we're going to take the element in row 1, which is -5, multiply it by -2. -5 times -2 is 10. We're going to add it to 3. That gets me 13. And then we're going to take 11, multiply it by -2. That gets me -22. Going to add it to -4, that gets me -26. And now that process is done. So I took row 1, multiplied it by -2, added it to row 2, and then put it in row 2. Now what we can see is the first column is what we want it to be in order to be in row echelon form. So the next step to this process is, in order to get in row echelon form, is we would like the element that's in row 2 column 2 right there where we currently have a 13, we would really like that to be a 1. Now I'm not going to touch row 1 because row 1 is actually fine. It has its 1 in its position. Don't want to do anything to that. The only thing I really want to do is change that 13 to a 1. And the simplest way to do that is to take row 2 and divide by 13 and then put it back in row 2. So what we want to do then is just take that row 2, divide by 13. So if I do that, 0 divided by 13 is 0. 13 divided by 13 is 1, and -26 divided by 13 is -2. Now our matrix is actually in row echelon form. Notice we have 1s down our diagonal, we have a 0 below. This is in row echelon form. What this allows us to do now is remember that the numbers to the left of this line, this dividing line, were coefficients of our variables. And so when we look at this bottom row, what that tells us then is the coefficient of x is 0, coefficient of y is 1. So that row, if we read it just off, it says that 1y is equal to -2, or y is equal to -2. Now if we take the first row and we write down what it said that x minus 5 times y, again the coefficients, 1x minus 5 times y is equal to 11. If you know that y is equal to -2, we can plug that in. And so what we're going to get is x minus 5 times -2 equal to 11, or x plus 10 is equal to 11, or x is equal to 1. That will give us a solution to our system of 1, -2. And I do suggest you check that as an answer to your system, but that does finish our first example. Now we're going to continue on with several more examples. I'd like to do one more 2x2 system and then 2 3x3 systems, and we will solve some more problems. Okay, as our next example, we are going to work with the system 3x plus 9y equal to 2 and x plus 3y equal to -4. Forming the augmented matrix will get us 3, the coefficients of x and y, 3, 9, 2. Coefficient of x is 1, coefficient of y is 3, and that's equal to -4. So here's our augmented matrix. Now remember that step 1 is to get a 1 in this very first position, row 1, column 1. We'd like that element to be a 1. Easiest way to do that is we do have 1 as our first element in row 2. So what we could do is we can interchange rows 1 and 2. And so I'm going to just interchange row 1 and row 2. Again, I'm going to number these rows so that we can see what I'm doing. So what I'm going to do is interchange those. So we're going to put the bottom row on the top and the top row on the bottom. Okay, now looking at our matrix, we can see that we do have a 1 in that first position of our matrix, which is good. That's what we want. Next step then is we would like to have a 0 in all of the elements below that in that first column. So I'd like a 0 right there in the very first element of row 2. In order to do that, again, I have a 1 in the first row, so what I can do is I'm going to add a multiple of row 1 to row 2 in order to get a 0 in that position. So what I'm going to do is I'm going to take row 1, I'm going to multiply it by -3, I'm going to add it to row 2, and then I'm going to put it right into row 2. So that what we can do then is, what we will end up with is our first row. Again, we're going to leave it alone. I have 1, 3, -4. Second row we get by multiplying the element in row 1, which is 1, times -3 is -3, plus 3 gets us a 0. We're then going to take 3 times -3, get -9, plus this 9, that gets us a 0. I'm going to take -4 times -3, which is 12, plus 2, which is 14. And we end up with this matrix right here. Now our next step would normally be to get a 1 right here in this position, but that's not possible with the 3 steps that we have. I can't interchange my rows, I can't multiply by a number to get a 0 to be a 1, and I've already combined my rows to get a 0 in the first spot. So what happens with this, if you recall when you solve systems, there are 3 possible types of solutions. You can get a single solution, single point where the 2 lines intersect. You can get infinite solutions where the lines are the same, or you can get no solution, in which case the lines are parallel. The example that we have here, when all of your coefficients in a row are 0, so it doesn't matter which row it is, but if all of the elements that represent the coefficients of your variables become 0, what that row actually looks like then is that implies that 0 is equal to 14. Now we know that 0 is not equal to 14. That's a false statement. And if you got that when solving a system with any of the other methods, what that implies then is that this system has no solutions. So that means our 2 lines were parallel to start with, and once you get a row with all of the coefficients 0, you can actually stop. It is either going to mean that you have no solutions, which in this case is what this is, 0 equal to 14. If that entire row, including the element that represents the answer, is also 0, so what you would end up with in that case is 0 equals 0, then that would be the case where we had infinite solutions to our system. But in this case we do have no solutions, and we are done with this particular example. Now what I think we'll do is move on to a 3 by 3 system, so we're going to move on to a slightly bigger system. Okay, so here we have an example of a system of 3 equations with 3 variables we want to solve, which is 2x plus 3y minus z equal to 6, x minus 2y plus 3z equal to -11, and 3x minus y minus z equal to 2. Again, the very first thing we're going to do is create that augmented matrix. So we're going to take our coefficients, 2, 3, -1, and our solution, 6. we're going to take 1, the coefficients in the next one, 1, negative 2, 3, negative 11, and 3, negative 1, negative 1, positive 2. So we're going to create that augmented matrix. Again, I'm going to number my rows. Now again, step 1 is to get a 1 in this very first position. So as I see this, we have a couple of choices. The easiest choice, I think, is actually to just interchange. If you already have a 1 somewhere in the first column, just interchange the two rows and put that 1 in the very first row instead. So what I'm going to do is I'm going to interchange row 1 and row 2. So all I'm going to do is put row 1 with where row 2 is and row 2 where row 1 is. So what we will end up with is 1, negative 2, 3, negative 11, and 2, 3, negative 1, 6, and 3, negative 1, negative 1, positive 2. So what I did was I interchanged row 1 with row 2, and so all I did was swap those two. Okay, so now our new rows. This is now our new row 1, row 2, and row 3. Now we do have a 1 in that first position in the first column, which is good. The next step is to get zeros in the two places directly below it. So what we're going to do is we're going to work with those one at a time. Again, what I'm going to do is, though, I am going to absolutely leave row 1 alone. So we're going to leave it alone. It's already happy. We've got 1, negative 2, 3, negative 11. And then what we want is a 0 right here below that where that 2 is. So where row 2 is, I currently have a 2. If I take row 1 and I multiply it by negative 2, and then I add it to row 2, then I will have a 0 in that first position, because 1 times negative 2 is negative 2, plus 2 is 0. So that's what I'm going to do. I'm going to take row 1, multiply it by negative 2, add row 2, and I'm going to put that right into row 2. So again, let's do that. So 1 times negative 2 is negative 2, plus 2 is 0. So that goes right here. Negative 2 times negative 2 is 4, plus 3 is 7. 3 times negative 2 is negative 6, plus negative 1 is negative 7, and negative 11 times negative 22 is, negative 11, sorry, negative 11 times negative 2 is 22, plus 6 gets us 28 right here. Okay, so now that step is done. I have a 0 in this spot right here. Now my next goal is to get a 0 in the rest of that column. So I do want a 0 in the spot right below it. The next goal is to get a 0 right here. Again, I am going to use row 1 because that's got a very nice 1 right there. So I'm going to take row 1. Now if we look in the row currently, there's a 3 right there. So 3 plus what gets me a 0? That would be negative 3. So if I take 1 times negative 3, I add it to row 3, and then I put that in row 3, I should get a 0 right there. So again, we're going to take 1, multiply it by negative 3, gets negative 3, plus 3, gets me the 0 that I do want there. I'm going to take negative 2 times negative 3, gets me 6, plus negative 1 is 5. 3 times negative 3 is negative 9, plus a negative 1 is negative 10, and lastly I got negative 11 times negative 3 is 33, plus 2 is 35. Okay, at this point now our first column is exactly like we want it to look in our row echelon form. I have a 1 in the first position and zeros below it. The next goal, remember, for row echelon form is we do want a 1 in row 2, column 2. So we do want a 1 right there. That's our next goal. So let's leave row 1 alone. We're not going to mess up the row that we already have here. And leave that one alone. Now what I do want is a 1 in that second position in row 2. It currently is a 7. And so what I'm simply going to do is take row 2 and divide by 7 and put that back in row 2. That'll give me a 1 there because 7 divided by 7 is 1. Now 0 divided by 7 is 0, so that's going to keep our 0 there. We don't want to mess up what we've already done. If at any stage you mess up a column that you've already fixed, you probably don't want to do that step. All right, 7 divided by 7 is 1. Negative 7 divided by 7 is negative 1, and 28 divided by 7 is 4. So that's our next step to this. I'm going to leave row 3 alone right now. I'm not going to touch that in this step. Okay, so here's our new rows. Row 1 now is fine. Row 2 is actually fine. Our last step, well, not last step, but our next step, I guess, is to get a 0 below that 1 in the second column. So it currently is a 5. In order to fix and get zeros in the second column, my suggestion is you use row 2 that we just managed to put a nice 1 right here. So what I'm going to do is leave row 1 alone. I'm going to leave row 2 alone. So I'm going to write those down. Now, what we want is a 0 right here in this position. If I look, I am going to use row 2. So I'm going to use row 2 to fix column 2. I used row 1 when I wanted to get zeros in column 1. I'm going to use row 2 when I wanted to get zeros in column 2. And if I had more than that, I would continue that pattern. So what I'm going to do is take row 2. Notice what I have currently in row 3 is a 5. So row 2 times negative 5 plus row 3 will get me a 0 right there. And I'm going to go ahead and put that in row 3. Now if we look starting all the way at the beginning, this is 0 times negative 5 plus 0 is 0. 1 times negative 5 plus 5 is 0. Negative 1 times negative 5 is positive 5. Plus negative 10 gets me a negative 5. And 4 times negative 5 is negative 20. Plus 35 is 15. Okay? Now we actually have one more step to get this matrix in row echelon form, and all we need is a 1 here in the element in column 3, row 3. So all I really want is a 1 right there. The easiest way to do that, again, what I'm going to do is leave those first 2 rows alone. And all we want is a 1 right there. So what I'm going to do is take row 3. I'm going to divide it by negative 5 and just put that right into row 3. That'll get me a 1 in that position. 0 divided by negative 5 is 0. So these are zeros. Negative 5 divided by negative 5 is 1. And 15 divided by negative 5 gets us negative 3. At this point, my matrix is in row echelon form, and I am ready to actually solve for my variables. So this part is actually called back substitution. It is the same kind of thing that you do when you solve systems with other methods. If we look at our bottom row, we can see that. Now if we take the matrix that we have, recall that the numbers to the left of this line were the coefficients of our variables. The very bottom row represents then the fact that z is equal to negative 3. If we use the row above that, then what this row 2 tells us is that y minus z is equal to 4. But we know that z is negative 3. So we do y minus a negative 3 equal to 4. That will give us that y plus 3 is equal to 4, or y is equal to 1. And if we use the top row of our matrix, what it represents is that x minus 2y plus 3z is equal to negative 11. And so that means x minus 2 times what we just found for y, which is 1, plus 3, which what we found for z was negative 3, is equal to negative 11. This is x minus 2 minus 9 is equal to negative 11, where that gives us x is actually equal to 0. So we have the solution to our system. We have that z is equal to negative 3, y is equal to positive 1, and x is equal to 0. Or we have the order triplicate 0, 1, negative 3. And that example is done. Okay, let's try just one more, just in case. You need to have one more example, and So let's use the example. X plus 2y plus 3z equal to 9. 2x minus y plus z equal to 8. And 3x plus 0y, so no y's, minus z is equal to 3. Now what you might want to do is stop this and try this on your own first, and then we'll walk through it. If not, let's walk through it together. First thing first, we are going to make ourselves an augmented matrix. 1, 2, 3, 9, 2, negative 1, 1, 8, and 3, 0, negative 1, 3. Now looking at our augmented matrix, we can see that we do have a 1 in row 1, column 1. So that step is done. Next step is to get zeros below that. So in order to do that, what I'm going to do is take row 1. I'm going to multiply by negative 2, add it to row 2, and put it right in row 2. So we're going to do this. I'm going to do a couple of steps all at the same time here. So I got 1, 2, 3, and 9. Leave our first row alone. All right, now if we take row 1 times negative 2, 1 times negative 2 plus 2 gets me 0. 2 times negative 2 is negative 4, plus negative 1 is negative 5. 3 times negative 2 is negative 6, plus 1 is 5. And 9 times negative 2 is negative 18, plus 8 is negative 10. That row is fine. Now, in order to, again, so we have a 0 in that spot, in this spot right here. We next step is to want a 0 right in that first position of the third row. And so what I'm going to do, again, is use row 1. I'm going to multiply this time by negative 3. I'm going to add it to row 3, and I'm going to put it right into row 3. Now what I want you to notice is that I have labeled my steps at each step along the way. This is not just for you. My suggestion is you do this too, because if you make a simple arithmetic mistake, it will make it much easier to find if you've actually made a note to yourself as to how you went from one step to the next, so that you don't have to start the problem all the way from the beginning. You can just check your arithmetic. Okay, so if I do 1 times negative 3 plus 3, this is going to be 0. 2 times negative 3 is negative 6, plus 0 is negative 6. 3 times negative 3 is negative 9, plus negative 1 is negative 10, and 9 times negative 3 is negative 27, plus 3 is negative 24. And so that's our new version of this matrix. Okay, let's continue on. Remember what the next step is. The next step is we want a 1 in row 2, column 2. And so we're going to leave that first row alone. In order to get a 1 right there, we're just going to take row 2. I'm going to divide it by negative 5 and put it in row 2. So what I've got then is 0 divided by negative 5 is 0. Negative 5 divided by negative 5 is the 1 that I want. 5 divided by negative 5 is negative 1. And negative 10 divided by negative 5 is 2. And I'll write down my third row here. Okay, so next step is to get a 0 below that 1. So what we're going to do is, again, leave row 1 alone. Leave row 2 alone now. The only thing we want to change is row 3. Now how shall we change row 3? What I want is a 0 in this position right here. So what I'm going to do, remember, if I'm fixing column 2, I'm going to use row 2. So I'm going to take row 2, I'm going to multiply it by 6 in this case, add it to row 3, because if we do that, then we get a 0 in that position. So what I'm going to do is row 2 times 6 added to row 3. If we do that, 0 times 6 plus 0 is 0. 1 times 6 is 6, plus negative 6 is 0. Negative 1 times 6 is negative 6, plus negative 10 is negative 16, and 2 times 6 is 12, plus negative 24 is negative 12. Okay, as our next example, we're going to look at the two-equation system. 3x plus 9y equal to 2, and x plus 3y equal to negative 4. We're going to first form our augmented matrix, which is going to be 3, 9, 2, 1, 3, negative 4. Now, steps from what we talked about earlier. First thing we do is we want a 1 in element 1, 1. And the easiest way to do that, right now it's a 3, but if we look, the easiest way to do that is to look down that column and see if there's a 1 in a different row. If there is, the best thing to do is just to interchange the two rows. And as you can see, row 2 does have a 1 in position 1. So therefore, all I'm going to do is I'm going to interchange row 1 with row 2. Okay, so this was row 1, this is row 2. We're going to interchange those two. So what we now have is the augmented matrix 1, 3, negative 4, 3, 9, 2. So step 1 is done. The next step to putting this in row echelon form is to get a 0 in every position of the first column except the first one. So we want a 0 in that first spot in row 2. And in order to do that, what I'm going to do is I am going to use row 1. So I'm going to take row 1, I'm going to multiply it by negative 3, because 1 times negative 3 is negative 3, and when I add it to the 3 that's currently in row 2, I will get 0. So what I'm going to do is take row 1, multiply by negative 3, add it to row 2, and then put that in row 2. We're going to leave row 1 alone, so don't just write row 1 down. We're using it, but we're not going to change it physically. Now, if I take 1 multiplied by negative 3, add it to that 3, we will get a 0 right here. If we take 3 times negative 3, I get negative 9, plus 9 gets me a 0. And if I take negative 4 times negative 3, gets me 12, plus 2 is 14. Now at this point, normally we would go ahead and we would try to get a 1 right here. But in this particular example, and in any example where this happens, if the coefficient parts of the row all end up zeros, like in this case. So this entire second row, the coefficients are all 0. What that actually relates to is the fact that if you read across that, that says that 0x plus 0y is equal to 14, or 0 is equal to 14. Now, if you recall solving systems of equations, there are 3 things that can occur when you solve a system. You can get one unique point, which is what we got in our first example. You can have the case where the lines are the same line, and therefore you would have infinite solutions, or you have the case where the lines are parallel and you will have no solutions. When we get something like 0 equal to 14, which is a false statement, what that does mean is that this system has no solution whatsoever. If we had infinite solutions, then the entire row would be 0. So what we would end up with is somewhere in our matrix we would get 0 equals 0. So we would have an entire row of zeros, not just the coefficient parts. But once that happens, once you get all zeros for your coefficients, you can stop solving right there. And because it is either going to be one of those special cases where we have no solution or infinite solutions. So the answer to our example in this case is that we have no solution to the system. And again, that relates to the fact that we do have parallel lines in the system. Okay, let's move on to an example of a 3 by 3 system. Okay, so my example is 2x plus 3y minus z equal to 6, x minus 2y plus 3z equal to negative 11, and 3x minus y minus z equal to 2. Again, first thing, let's form our augmented matrix. So we're going to have 2, 3, negative 1, 6, 1, negative 2, 3, negative 11, and 3, negative 1, positive 2. Now remember, in row echelon form, first thing we would like is a 1 in the upper left of our matrix. And again, what I can see is that's not a 1, but there is a 1 as the first element in row 2. So what I'm going to do in this particular problem is just interchange row 1 with row 2. So I'm going to take row 1, put it where row 2 is, and row 2 and put it where row 1 is, so that we have a 1 in that first position. So we're going to get 1, negative 2, 3, negative 11, 2, 3, negative 1, 6, and we're going to leave row 3 where it was, just 3, negative 1, positive 2. Next step was to get zeros in each of the other positions down our first column. So what we're going to do, and let me number these rows. So again, when I do that, I am going to leave row 1 alone. It's got the 1 where I want it, and I'm going to leave that one alone. What I want is 0 in this position right here. In order to do that, what I can do is I can take row 1. I'm going to multiply it by negative 2, because when I add it to my old row 2, that will give me a 0 to put in this new row 2. So what we're going to do is take negative 1 times our first row and add it to our second row and go across. So 1 times negative 1 plus 2 gives me this 0 right here, which is what I'm going for. Continue across the row. Negative 2 times negative 2 is 4, plus 3 is 7. 3 times negative 2 is negative 6, plus negative 1 is negative 7. And negative 11 times negative 2 is 22, plus 6 is 28. And so there's our new row 2. Now, next step is I want a 0 in this next position here. Again, I am going to use row 1 in order to get the zeros below it. So once we get row 1 to be a 1, we're going to use row 1 to get zeros as the first position in any row below it. So what I'm going to do is still use row 1. I am going to multiply, in this case, looking up here, I have a 3, so 3 times negative 3 is going to get me 0. So I'm going to take row 1, multiply it by negative 3, add it to row 3, and put it in this new row 3 that we have. So, looking back, 1 times negative 3 plus 3 is 0. That's good. That's what we want right here. Continuing across, we're going to take negative 2 times negative 3, which is 6, plus negative 1 is 5. Continue across, negative 3 times 3 is negative 9, minus 1 gets me negative 10, and negative 11 times negative 3 is 33, plus 2 is 35. Okay, so now our first column is correct in row echelon form. The next step, if you recall, is to get a 1 in the second row, second column. So what we want is a 1 in this position right here. And now, in order to do that, I think the easiest thing to do is simply to take our row 2 that we have and just divide by 7. And then we'll put that in row 2. Now what we're going to do is leave the other rows alone. So again, don't do anything to those. So I'm not going to touch row 1. I'm not going to touch row 3. The only thing I'm going to do is take row 2 and divide by 7. 0 divided by 7 is 0. 7 divided by 7 is 1. Negative 7 divided by 7 is negative 1. And 28 divided by 7 is positive 4. So now we have this matrix. The next step in row echelon form is to get a 0 in this position right here. So 0's below our diagonal. So once we get the 1 in position 2, 2, we're going to get 0's below it. So the only thing I want to change in this step is row 3. So I'm going to leave row 1 and row 2 alone. I'm going to write those down. Okay, now when we want to put zeros in column 2, we are going to use row 2. So we used row 1 to put zeros in column 1. We are going to use row 2 to get zeros in column 2. And so what I'm going to do is I want to have, remember, a 0 right here. This is what I want, is a 0 right here. So if we look, I have a 1 in the spot above it. So if I take row 2 and I multiply it by -5 and I add it to row 3, then that should get me a 0 right there. Now we need to do the entire row, but 0 times -5 plus 0 is 0, so it does not mess up that first column. If any step along the way you do changes what you've already done, stop and don't do that. Rethink what you're trying to do, because you don't want to undo a step you've already done. Now here, if we take 1 times -5 plus 5, we will get the 0 that we wanted right here in this spot. Continuing across, -1 times -5 is 5, plus -10 is -5, and 4 times -5 is -20, plus 35 gets me 15. The very last step to this process is we want a 1 in this last position right here in row 3. And so what I'm going to do is, we've got -5. All I'm going to do is divide that row by -5 to get me a 1 right there. So I'm going to take row 3, I'm going to divide it by -5 and put it back in row 3. We're going to leave our other rows alone. So 0 divided by -5 is 0, 0, -5 divided by -5 is 1, and 15 divided by -5 is -3. Now we have a matrix in row echelon form, and we are ready to use substitution to go back and actually find our variables. If we look at the third row of this matrix, remember, the first is the coefficient of x, coefficient of y, coefficient of z. So what we actually get from row 3, all that tells us is that z is equal to -3. So we have one of our variables. If we look back at row 2, it gives us that y minus z is equal to 4. But we know z is -3, so we're going to get y minus a -3 is equal to 4, or y is equal to 1. And if we go back to row 1, it tells us that x minus 2y plus 3z is equal to -11. That gives us x minus 2 times y, which we just found was 1, plus 3 times z, which we found was -3, has to be equal to -11. This is x minus 11 equal to -11, so x is equal to 0. And now we have the ordered triplicate, which is the solution to our system of the point 0, 1, -3. Now my suggestion is you do check these answers before you decide you're actually done and you have the correct answer. Let's do one more example. Okay, so our last example is x plus 2y plus 3z equal to 9, 2x minus y plus z equal to 8, and 3x minus z equal to 3. When we form our augmented matrix, we're going to get 1, 2, 3, 9, 2, -1, 1, 8, and 3, 0, because there's no y's in that equation, -1, +3. Now we do have a 1 in our element 1, 1, row 1, column 1. So step 1 of our process is actually done. Remember, the next step is to get zeros in the rest of the column. So what we're going to do is leave row 1 alone. I'll do more than one step this time. So what I want is a 0 right in this spot. So if we take row 1, multiply it by -2, and add it to row 2, we should get a 0 in that spot. So 1 times -2 plus 2 is 0. 2 times -2 plus -1 is -5. 3 times -2 is -6, plus 1 is -5. And 9 times -2 is -18, plus 8 gives me -10. So this is my new row 2. Now I'm going to continue and do the next row at the same time. What we currently have is a 3 right here. Again, what we want is a 0. So I'm going to use row 1. Remember, we're going to use row 1 to get zeros in the rows below it. So again, going to use row 1. In order to get a 0 in that position, we need to multiply row 1 times -3. We're going to add it to row 3. And so 1 times -3 is -3 plus 3 gets me my 0 I want. 2 times -3 is -6 plus 0 is -6. 3 times -3 is -9 minus 1 is -10. And 9 times -3 is -27 plus 3 is -24. Okay, and that's our new row 3. Now the next step in this process is to get a 1 in the middle element in row 2, column 2. So we're going to leave row 1 and row 3 alone. And all I want is a 1 right there. So I'm just going to take row 2 and I'm going to divide by -5 and put it in row 2. That would be 0. -5 divided by -5 is 1. Again, 1. And -10 divided by -5 is 2. Okay, so now we have this matrix. Okay, next step, remember, 0 below that 1. So we want a 0 in the column 2 of row 3, where the -6 currently is. In order to get zeros in column 2, I am going to use row 2. So again, I'm going to leave row 1 and row 2 alone. We have those the way we want them, so we're going to leave those alone. And all I want to do is change row 3. Now what I want to do is I'm going to use row 2, so I'm going to take row 2, I'm going to multiply it by +6, because when I add that to row 3, I get a 0 in that position. So 0 times 6 plus 0 is 0. 1 times 6 plus -6 is 0. 1 times 6 is 6. Plus -10 gives me -4. And 2 times 6 is 12. Plus a -24 is -12. Our last step to get this matrix in row echelon form is we want a 1 in this position right here. So again, we're going to leave rows 1 and 2 alone. And all I'm going to do is take row 3, and I want a 1 right there, so I'm just going to take row 3 and divide by -4. And put that in row 3. So this is 0, 0, 4 divided by -4 is 1, -12 divided by -4 is +3. And now our matrix is in row echelon form, and we are ready to use substitution in order to be able to solve our system. Again, if we look at row 3, we have 0x plus 0y, 1z equal to +3. If we look at row 2, that tells me that y plus z is equal to 2, but z I know is 3. So y then is going to be equal to -1. And if I look back at row 1, I know that x plus 2y plus 3z is equal to 9. So x plus 2 times negative 1 plus 3 times 3 is equal to 9. This is x plus 7 is equal to 9, or x is equal to positive 2. It gets us the ordered triple of 2, negative 1, positive 3. Now again, my suggestion is that I did number my rows as I went, and I wrote down what I did at each step. My suggestion to you is you do the same, because if you have to find an arithmetic mistake, it does make it a lot easier to remember what you did at each step along the way. And again, there are a lot of arithmetic steps to these problems, so please check your answers when you're done. Okay, thank you.